So, a bit of a different talk. And there were a few people that said they were networking people in the room. So we're going to talk a little bit about how to do some automation in general, and how to use Ansible as part of an automation approach, but not in its entirety. So this is the idea. My screen's not happy. Everyone look this way. Is that? Oh, it is. What was it? Okay, just look at that one. It'll figure itself out.
Everybody, close your left eye.
Yeah, exactly. We'll move to that side of the room. Right, so introduction to Nokia. You probably all know us. What is model-driven management? This is probably new for people who aren't networking people. Quick overview of CI/CD pipelines and then a demo. And I'll spend most of the time on the demo. So I will rocket through the rest of it. So Nokia, you probably all know us for that. We do other things too. And in fact, actually, if you look back to the history, it's a pretty impressive place to work. We have 9 Nobel Prizes, 8 for physics and 1 for chemistry. Slightly weirdly, we also have 2 Grammys, 2 Emmys and an Oscar. Which is mildly strange. Not me, individually, I'm not relaxed. How did you get an Oscar? The Oscar, I believe, was for a documentary on it's like the sound horn resonance something. But most notable, some of the things that came out of Nokia, the transistor, kind of important that we're going to review today, and Unix, which is probably the most important for a lot of us. So, part of the Bell Labs infrastructure. But today, this is the bit that I work in, and we make those things. They are routers, so they look after your internet traffic. And I work on SROS, which is the software that runs on them. So we're going to talk a little bit about automating those. So model-driven management. For a while, anyone who's been in networking has known we've always wanted a way to manage multiple vendors' equipment. We'll epilepsy that side again. So we've always wanted a way to manage multiple vendor networks in a pretty easy way and to automate that. And we've tried for many years, and the best we came up with was SNMP. Now, however, we're moving to a way where we can provide models that reference and explain how you model a device, or a piece of software within a device, or a feature, or even the CLI. And we want that representation to be consistent, and we want it to be able to be read by humans pretty easily, but also by machines really easily. The whole point here is to automate stuff. But if we're all doing different things, automation carries on being hard, and you need to have an interface, and you need to understand the languages, and every time you need to compensate in an automation system, you are going to cost. And you're adding cost to your workflows. So what the networking industry is generally moving towards is Yang. So Yang is a modeling language. It's defined in an RFC. And it will go through and allow you to model a tree structure of pretty much anything. You could model your fridge if that's what you felt like modeling. It's a flat text file. It's very easy to read. Anyone who's been programming, there's a lot of pretty common constructs in there. And it'll be very familiar. And because it builds this tree approach, it actually builds up something that's really quite good for configuration in networking devices and state information in networking devices. Actually, the root of most networking devices is a CLI that's built on a tree. And this is no different. It essentially builds that from flat text files, which is great. You can parse it into tools and output your entire tree structure without even having a router. And in the case of what we've done at Nokia, that is going to be directly relevant to the CLI. So you can essentially output the CLI tree without even having a router. The other thing we're going to talk about, show a little bit in the demo, is configuration data stores and state data stores. So the concept of data stores exists as part of the netconf RFC. And configuration data stores store data, so they're an instantiated tree containing configuration data. And other data stores are instantiated trees containing anything else. And state information in a root is a good example of that. What can we do with automating this stuff? If we've got Yang models, we can do things on the fly. So we can do, and we're actually going to do it a little bit today, we can auto-generate configuration for devices from snippets or templates or different formats. And you can do that in a multi-vendor way, so when you've got the right models. You can also generate user interfaces. This is actually our management tool for routers. And the GUI in here is auto-generated again on the fly. So if you change the Yang model, the GUI changes itself. So that's the background. CI/CD pipelines, probably everyone here is familiar with what these are. But if you're not, continuous integration and continuous delivery, generally talked about in a code setting and software development setting, can apply equally well to networking, and actually we're going to show you that today. So continuous integration, you're doing your coding and your building, so in the case of network configurations, that's writing our device configurations, validating them syntactically, and going away and testing them. Is this actually going to work? And then continuous delivery, the ability to deploy on a lab environment, then do a staged deployment onto the main live network. So canary device, try one device, then try a small group of devices, and then expand. Keeping an eye on the feedback as part of your continuous delivery loop. So when I did my one device, it was great. When I did 10 devices, suddenly I got a bunch of network problems, or I got a bunch of tickets come in. Maybe I want to roll that back. So how does Ansible fit into this? Well, it's obviously a very popular tool. You can see, just looking around the room, there's an awful lot of people here in your own time for a tool that's extremely popular. It's very, very good at automating tasks, pretty mundane tasks, and actually a lot of networking stuff is pretty mundane tasks. Go and grab the configs from my router, do it every night. Okay, not exciting, but useful. Very good for on-the-fly configuration generation, actually, with the Ginger integrations. So if you take the Ginger templates, you can actually generate configs really well. It's really good for that kind of stuff. The one that's interesting in this demo and for us as networking people is built into it is netconf connections and CLI interfaces as well to various router types. So that's really, really useful and makes integration with networking devices really simple. Especially if, as these kind of worlds are colliding, networking worlds are colliding with systems worlds, and finding people from both areas crossing the boundary, and the fact that you can do this in one tool, one interface is really useful. And of course, we have the ability as vendors to contribute into Ansible as well if you wish to. And you will see some of that today as well. So we talked a little bit about this. I'm going to use this as the example. So maybe my master branch is my configuration. So all my configurations are stored in a source repository, like GitHub or GitLab, for example. And they're all under revision control, which means that multiple people can look at them, edit them, we know what's coming and going. So we have more control than we have typically had on router configurations. Generally, people in operations environments make changes and store the config later. And you have a history from the tickets, etc., but there's not so much a history of the configuration before it's applied. You normally have a history of what happened after it was applied. And it allows us to create development branches as well off of this. So if I want to go and do a planned works, which is what we're going to do in the demo, I can branch off from here, do my planned works, do all my testing, run my continuous integration and deployment stuff on my planned works branch. And then only when I'm ready to actually deploy, check it back in, and then have the deployment processes go and deploy automatically as well on the network. And it may be that actually you have another branch off here. It says, I'm kind of done, but now send this away to do real full testing in your labs. And then continuous delivery. So this is an example, and by no means the only or right way to do it necessarily, of an approach for a continuous delivery. Deploy to the lab, go away and do lab testing, and that could be using a number of tools. Robot frameworks are a good example. Then do the canary deployment, and then do this phased deployment approach. The key bit, though, is picking the right tool for the job, and it's not always going to be one tool. There may be a whole variety of tools you want to use. So we're going to do almost exactly that in the demo with a variety of open source tools. So hopefully this will work. This is what we're going to use in the demo. So we have two 750 SR1 SR routers, so from Nokia. They're running SROS in our model-driven mode. And we're going to talk to them with both model-driven CLI and Network. And we're going to run a Jenkins pipeline. We're going to use GitHub, and we're going to use some of the GitHub actions. And we're going to use Ansible, both with and without imports from Nokia's contributions to Galaxy as well. And we'll talk through the playbooks. So, first thing for the demo, we have an empty branch, or an empty repository sitting in GitHub. That's going to be our master branch. And I'm going to flick it backwards and forwards a little bit from presentation mode. Use the screen completely. So, here's the GitHub repository. And you can see it is empty. So readme and valid. So the first thing I want to do, you will see if I leave it in that mode, it's easier to fix. I'm going to baseline my routers. So my routers exist, they have a configuration, and in fact we can log on to them. So here's a router. So it's up and running. So here's a router, it has no line cards provisioned in it at all, so it's not the most effective of routers. And we're going to, as part of the demo, provision these line cards so that the actual hardware comes up and you can start using it. So let's baseline those configs. We'll go away and grab those configs. We're going to do that with an Ansible playbook. This is the playbook that's going to do it, and it's split into a number of parts. So I'll run it quickly. You can see what it was, what it does, and then. So this is going away then and talking to those live routers, getting the configuration. It's getting the configuration using the network CLI plugin connection. Sorry. And it's using the CLI command module. In order to go and get connection to the router, it's typing a bunch of commands. And there are other ways to do this, and we'll show some of the other ways later. This is a way. If you want to do it by CLI, you can. And it's getting the configuration of the router in JSON format, because that's a nice, useful format to have a configuration of the router. So we're done. It's finished. And what it's then doing, having got those, it's then checking it into that repository. So our main baseline repository has a bunch of router configs. These two routers, I've only got two routers for the demo. They're here, and there's my config in JSON. So that's the config of the router. It has everything in it that's in the configuration. So now we're going to do our planned works. Well, let's talk about the playbook first. So the first thing the playbook does here is checks out the Git repo, puts it locally so that I can then access it. And that's on localhost, so just on the server I'm running it on. Then we're going to run on our routers, the connection, network CLI connection, and this piece here, the collections, Nokia.SROS, is importing the SROS Galaxy collection that we can then utilize. And then we're running the CLI command, the standard CLI command approach, And this is the command we're actually issuing to the router admin show configuration JSON. That's our running configuration, and then we're going to write that out to a file. That's all that's doing. And then part 3, we're going to take that file and just put it back into Git. Now the Git module in Ansible for committing and pushing has some work to be done. So actually it's easier to do it straight in the show. So that's that playbook. Now what we're going to do is create our branch for our planned works, and we're going to make some router configuration in that. So let's do that. Okay, so I'm going to create a branch. Just doing it here because it's prettier for the screen rather than doing it on CLI. So let's call it and works today. So I've created my branch, and I'm going to do my editing of my repo. So here's my repository. Here's that JSON config that we had. That's a bit hard to read and work with, so let's make it a bit prettier. There we go, that's a bit easier. And I'm going to take some config for provisioning those cards. I'm going to do it in JSON. I've cheated, I've just do it in another window so I can cut and paste it. So let's just add that to my router. So that one, and we put it on both routers. Just as we can. Okay, so there's my changes. Did and works. So I commit it. Now at this point, nothing's happened. We'll see. I'm going to publish my branch. And now we see I have a planned works today branch here. What I have happening in here is, so here's the changes I made here. Have a look, you can see it's down here, there's my card statement. But I also have a GitHub action running to verify and validate my config. So this is part of that continuous integration piece. So what it's doing here is it's taking the config in JSON. I'm going to take the Yang models that are available on GitHub for Nokia, for the Nokia routers. I'm going to compile the Yang models. And then I'm going to validate my JSON config against the compiled Yang models to make sure that it's valid for the router. So I already know ahead of time it's going to be a correct config. And I'm going to auto-generate the config that's actually going to be sent to the router in XML on here, and I'm going to commit that back into the same router, into the same branch, and work branch. So it's validating the config I did is correct. It's auto-generating using the Yang models the right config for the router in netconf, ready for netconf in XML, because netconf takes XML. So that passed, so the demo is going well. This is good. And I now see in my branch, I have 2 extra files. So here's my original file, my JSON file. Now I have each router config in XML. Great. There it is in XML. It's auto-generated. All the relevant namespaces are put in. And if I search the card, you can see the router configuration is actually going to go on the router. So that's in the correct syntax. It will work for the router. Because we already knew that. We didn't need to touch the router. We have all the models. Okay, so once my plan works is ready, now I actually want to deploy it onto the network. So let's have a look at these again. So a reminder that the router has no line cards. So we've done that piece, we've done that piece. Now what we're going to do here is we're going to check that branch or merge that branch back into the master. And that in turn is going to, once it's approved by me on the master, on the pull request, it's going to kick off my Jenkins pipeline which in turn is going to use another Ansible playbook to deploy all of those configurations using netconf in a completely vendor agnostic way here. Standardized netconf straight to the routers using the configurations we just generated on the fly. So let's do that. So, full request, which you can see the diff down the bottom, standard. And the configs, merge, yes. And delete branch. So I now have my XML files existing in my master. And here is my Jenkins running in the background. And this is going to pick up the changes. In fact, there's been a change. And it's going to run it. I can kick it if it's easier. Let's see if we can run it. Let's kick it. So this in the background is now running. I assume this works. It's now running Ansible from within Jenkins as well to do the deployment straight onto our network devices.
So your Jenkins pipeline is not doing much else than just...
No, it's just for the purposes of monitoring the repo and then just kicking off the Ansible script. Yeah, it's not doing much. So here, we did some munching around with the XML namespaces and replaced some footers, so we did some textual modifications. And then just a straightforward configuration to the router, which is done. And if we have a look on my router now, my line cards are now configured and in upstate. So it's configured them straight away. And this is the playbook for this one. So just want to change it. So again, it's in a couple of parts. First thing we do, again, grab the Git repo, exactly the same as the previous one. I needed to install NC Client purely because I'm using NC Client as part of the netconf module in Ansible, and it didn't exist in my Jenkins container. Then on my routers, I'm going to use the netconf connection plugin, and I do my kind of munging in my file. And then down here, this is the one that's actually doing the main work. It's very simple. It's using the netconf config module, which in turn, if you know netconf, takes an exclusive lock of the configuration, makes a change to the candidate configuration store, because I've got target candidate. Then it will commit it, and then it will release the lock all in one. You can do it with the netconf RPC as well and separate them into 4 actions if you like. And then we're just looking up a file, so the XML file that we created, and using that as the content. And the only thing that we did that was slightly different down here is the Ansible network operating system was Nokia.sros.md, and MD stands for model driven. I have one more playbook before pizza. This is very straightforward. This is a playbook that just allows you to get information from the router in any format you like using tags. So XML, JSON, or YAML, and either the configuration or the state information. And it's very simple. It's using the connection, using netconf get now, display an XML. We pass the relevant filter in for netconf, and that's about it. So let's just run that really quickly. So let's just run, and let's get, for example, the state information for us to config is quicker in XML. We saw it in JSON in the original playbook, so now let's just grab it in XML. So again, it's just going away, talking to the routers directly, and pulling the information, and then writing that out to authority. and there's my XML file with the root configuration. So very handy, very simple to use, very easy, and if you're automating a big router network, really quite useful, because I did it on 2 routers, but you can do it on thousands quite happily. So, just like the screens. So that's pretty much it. If you want to have a look at some more examples, there's the developer portal from Nokia you can look at, network.developer.nokia.com. Other than that, any questions?
Thank you, James. Of those 2 people, and they